So this is roughly where we left off. We talked about the theory of supply. A supply curve is if you give a supplier a price, the supply curve tells you how much the producers are willing to sell at that price. So it's a map between a bunch of different prices, and for each of those prices, it tells you what the quantity supplied would be for sellers overall in the market. And we sort of finished up last time thinking about why does this supply curve have this upward slope? The reason is that opportunity costs of those resources increase as you divert more resources away from other things to produce gasoline. So in the short run, you can think about a producer of gasoline or a supplier of gasoline. If they want to make more gas right now, they have to divert petroleum away from potentially other valuable uses. Petroleum can be used for making plastics. It's used for producing asphalt, for paving roads. It's used in motor oil. It's used for jet fuel. And if you wanted to make more gasoline, you'd have to divert some of that petroleum away from those other uses. And as you do more of that, as you divert more and more petroleum away from other stuff, you start having to divert it away from more and more valuable types of goods and services. So the first, kind of like in your homework one problem with the problem one with the farmer having different quality of land, they're always going to start by farming the land that is most productive, that's most fertile, that has the least amount of work they have to do in order to produce on that land. And then only if they want to produce more than that will they start to move onto more marginal land. Same is true for any kind of good. So if you want to produce more gasoline, you might divert some petroleum away from low value products. But then as you want to produce more and more, you have to keep diverting petroleum away from higher and higher value products. And that opportunity cost, therefore, is going to go up as you do that. So that's a little bit of intuition of why these supply curves have this upward slope. So at a point in time, a supply curve is a map between prices and quantities. It's a bunch of price quantity pairs. But there's things that can shift the entire supply curve. So a shifter of a supply curve is anything that's not the price, which could change how much producers are willing to supply. So if for example, these are some of the things that shift supply, the prices of inputs can shift supply. So if this is what your supply curve looked like in the initial state, let's say the price of some complementary input, or wages, either wages are going up or certain types of materials are going up in price. They're becoming scarcer and they're becoming costlier to acquire. That's going to be something that forces this supply curve up. So now, to produce like a given quantity, in order to produce Q bar, for example, suppliers are going to require a higher price than before because their input costs have gone up. So that's one thing that can shift the entire curve and make producers willing to supply a little bit less or requiring a higher price to supply the same amount that they did before. We can also think about technology. So if production technology is improving, if it's getting easier to make this or that, if the processes are becoming more efficient, that can be something that actually shifts this out and makes suppliers willing to supply more at a given price because they're able to do so more efficiently. And expectations about the future is also something that will do that. So with expectations, the producer, if the producer expects that in a couple of years the price of this good is going to go way up, they might prefer to hold on to it today, not sell their reserves today, but hold on to them and wait for a time in the future when they'll be able to make quite a bit more than they would be able to make today by selling that stuff. So expectations about the future could affect how willing suppliers are in the present to sell this or that into the market. So those are all things that can shift the entire curve. So we have demand. Demand is kind of like the marginal benefits of consumption or use. Supply, a supply curve is kind of the marginal cost curve for producing or supplying that good or service. And those two come together in the market. Buyers and sellers get together and exchange, and an equilibrium price and quantity emerges from that process. And you can think about this market equilibrium in a couple different ways. The first way that I like to think about it is from a quantity perspective. The equilibrium quantity is the quantity where all the potential beneficial trades are exhausted, where all the opportunities that buyers and sellers have to make each other better off through exchange, all those opportunities are already captured. So an example of that would be if, let's say we have this supply and demand curve here. Again, demand is marginal benefits, supply is marginal cost. Let's say that we're at Q1. So Q1 is what's being produced and sold to consumers. Consumers' marginal benefits at Q1 are way up here. Producers' marginal costs are way down here. And so there's a big gap between the benefits of doing something and the cost of doing something. It costs a lot less than what people would be willing to pay for it. That suggests that there's opportunities for beneficial trade. If we could increase quantity, we could get more benefit out of that quantity than what it cost us to produce that thing for. So that gap, at Q1, that gap is equal to that vertical distance. If Q1, or if the quantity increases a little bit to say this level, there's still a gap between marginal benefit and marginal cost. You increase that a little bit more, there's still a gap. And then eventually you get to a point where there's no more gap, where there's no more opportunity for sort of money on the table to be snatched up. And so that's kind of that's an idea of an equilibrium where there's no more benefit from changing quantity. We've already captured all the possible benefits from changing the quantity. Same thing can be true for if you've overproduced something. If we have a quantity like Q2 where the marginal cost is a lot higher than the marginal benefits, then you're sort of throwing away resources for each of these units. You're producing something that it costs you more to make than what people are actually willing to pay for. And so if you produce a little bit less, you can reduce that gap. You reduce the gap between marginal costs and marginal benefits. If you move to the left a little bit more, you can reduce it even more. And again, eventually you get to a point where you no longer have a gap between marginal benefits and marginal costs. And that's why that's an equilibrium point. It's because nobody has an incentive to change their behavior at equilibrium. There's no more opportunities for gains from changing the quantity. So that's kind of a way to think about equilibrium from a quantity perspective. You can also think about equilibrium as being a price at which there's no shortage or surplus of goods. So let's say we have a set of supply and demand curves like so, where P1 here is the price, and that price is high. At that high price, consumers are only willing to consume QC, whereas producers at that high price are willing to supply QP. And you have this gap. You have suppliers willing to supply a lot more than what consumers want. You're going to get a surplus, and so stuff is just going to be sitting around on the shelves, not doing anything. You're going to have a bunch of reserves that aren't able to be sold because the price is too high. You've produced too much stuff, and people don't want it that much. But the way that you can eliminate that surplus is by having the price fall. So eventually, if you reduce the price, you make it more attractive to consumers. You make more people want to buy it, so consumers will want to buy a little bit more. Producers, if you drop the price, producers will want to produce a little bit less. And eventually, again, you get to a point where the quantity supplied and demanded is equal and the surplus is eliminated. So the equilibrium price will eliminate that surplus of goods. The same thing is true if the price is too low. If the price is too low, producers don't want to produce that much. They only want to produce QP. Consumers at that low price want to consume a lot. They'd like to consume QC. You've got more people wanting the good than people willing to supply it. You have a shortage. If that price goes up, you're going to incentivize more production of that good. More producers are going to find it attractive to produce the good. Consumers are going to find it a little bit more costly than before. They're going to want to try to cut back on their consumption, and then eventually, as before, we get to a point where that gap is eliminated. There's no more shortage. So that's just a second way of thinking about equilibrium in a market. You can think of it as being the quantity that sort of maximizes the gains, that sort of captures all the potential opportunities. And you can also think of it like the price that eliminates both shortages and surpluses. So I talked about the efficient quantity being the one that maximizes the gains. We can get a little bit more precise about that and give some names to some different things here. So I'm going to call the area this upper triangle is area A, the lower rectangle is area B. Let's think about this from the perspective of a consumer. So consumers have a demand curve, they have a marginal benefit curve. There's a price. At that price, they want to consume a certain quantity. We're going to call that quantity Q. We can figure out the total benefits to consumers by actually just calculating the area below the demand curve. So the total benefits to these consumers of consuming quantity Q is the entire area below the demand curve. That's the total benefits to consumers for consuming that good. It's A plus B. A plus B is the total benefits. If they want to get Q units, they have to pay price P per unit. So they have to pay price P per unit. They're buying Q units. And so P times Q is going to be the cost to the consumers. So the area B is actually the area B is what represents P times Q. So B is going to equal the costs. And so if we take the total benefits minus the costs, we get area A, which is what's left over. That's what's left over after you subtract off the costs from the total benefits. So area A, in this case, is the surplus that consumers get by being able to consume quantity Q and pay price P. That's the surplus. That's consumer surplus. We can do the same exercise for producers. We can say that we can maybe, let's call this area C. Let's call this area D. So area C is this triangle. The lower triangle. D is the upper triangle. When producers sell Q units into the market at price P, they get P times Q, right? They get P times Q, which is equal to the area D plus C. So that's their benefits. You can also think of that as their revenues. The revenues are their benefits. But then in order to produce Q, they have to incur production costs. The total production cost that they incur is given by the area below the supply curve between 0 and quantity Q. So their costs are given by area C based on that logic of the the area below the supply curve up to Q being their costs. C is their costs, right? And so D would be their surplus. D would be the producer surplus, right? So you're always just finding the total costs. You're taking the total costs and you're subtracting them from the total benefits. Whether you're looking at consumers or producers, that's the procedure that you're doing to find the surplus that accrues to those parties, right? And so this is just a summary of what I just mentioned. We have consumer surplus being the difference between a consumer's maximum willingness to pay and what he or she actually pays. That's what this area up here was. This is their consumers were willing to pay an amount up here. They only had to pay an area down here or an amount down there, and so they get to capture whatever benefit is there in between. Similarly, for producers, there's a difference between the selling price and what it cost them to produce that. So that the selling price was P. They were able to obtain P, price P for every unit, but it only cost them this amount given by the supply curve. It was a different amount for each unit, but each of those units was cheaper to produce than with the price that they could get. And so they're able to capture some surplus, and that was given by area D. Okay, and this is kind of a useful approximation for the benefits of these market transactions to various parties. It doesn't capture everything that we care about necessarily, and we'll talk about that more in the next section where we introduce externalities. But it does capture. It's an approximation of a lot of the important gains that are being obtained by different parties as a result of being able to make those market transactions. One other thing I wanted to get to before wrapping up this micro section is this idea of introducing a tax into a market. There's a couple different ways you can do this. What I think is the most intuitive is to think about the tax as an extra cost to the producer. So the producer has a building that they rent, they have workers that they have to hire, they have materials that they have to acquire, they have machines that they have to operate and maintain, they have electricity they have to buy. And then you can think about the tax as an extra cost that they have to incur. It's an extra bill they have to pay. In this case, it's not a bill to the owners of the resources, it's a bill to the government for transacting. So remember, if costs are going up, if suppliers have an extra cost, that's essentially something that is going to increase their marginal cost of production, and you can represent that by an upward shift in the supply curve. So you can think about this blue line was the original supply curve. This orange line is the supply plus the tax. The tax is like an extra cost to the supplier, so it increases the marginal cost to produce that good. Okay. Now, it's helpful here to make a distinction between the price that the producer receives after the tax and the price that the consumers pay in the market. So the quantity that's going to be produced, we can call that, I'm going to call that QT for the quantity, the equilibrium quantity under the tax. Now the producer, this equilibrium quantity QT is going to be associated with, some consumer price. So consumers are going to be paying the new equilibrium price in this market. If you consider the intersection between the supply with tax and the demand curve, that new equilibrium price is going to be this new price P. And I'm going to use subscript P. I'm going to call this P const to represent the price that the consumer pays. So consumer, if you go to the store, the price that you see listed on the label is going to be the consumer price, but the producer price, essentially the producer gets that price per unit, but part of that price they have to pay to the government. So we can almost think about the producer as receiving a different price than what the consumer is paying. So I'm going to call this this red, the level of the price here that the producer receives. I'm going to call this P prod. So the producer literally receives P cons. It receives the consumer price, but he has to pay a certain amount of that to the government. So the net price, the price that he receives after he pays his tax, is P prod, which is a little bit less than P cons, which is equal to the vertical distance between the old supply curve and the new supply curve, because that's the amount of the tax. That's the amount that the supply curve shifted up. So we're going to apply the same logic as we did before. Remember, the consumer surplus is the area below the demand curve and above the price that the consumer pays up to the quantity that they consume. So the consumer is capturing surplus equal to this teal area. The producer is capturing surplus equal to the area below the price he receives and above the production costs. So the producer is getting surplus, which looks something like that. That would be the new producer surplus. There's an area in the middle which is equal to the tax revenue. So if the per unit tax is equal to the difference between P cons and P prod, so it's the height, it's sort of the height of this rectangle between P prod and P cons. That's the per unit tax, and the government collects that per unit tax for every unit of good that's sold. And so the total tax revenue is equal to that green rectangle in between the producer and consumer surplus. And then the final part that's worth pointing out is that there's this extra area out on the right-hand side here, which we call the deadweight loss. Notice that after the tax is imposed, the quantity that's produced goes down from Q star to QT. There's a reduction in the quantity. That represents a missed opportunities for mutually beneficial exchange. So for the units between Q star and QT, marginal benefit was higher than marginal cost. So it was possible for producers and consumers to come to mutually beneficial exchanges for the units between QT and Q star. The marginal benefits or the level of the demand curve was higher than the marginal cost curve. So those were potential benefits that could be captured. Because the tax artificially increases the price, though, the quantity goes down. The equilibrium quantity in the market has to decrease. And so those mutually beneficial exchanges are precluded from happening. Those things are no longer possible because of that artificial increase in price due to the tax. And so that's what that deadweight loss is. Those are missed opportunities for people to trade with one another because there's been a artificial inflation in the price as a result of the tax. So that's a way to sort of graphically analyze a tax. I like to think about the tax as being something that you tack onto the supply curve, increase the height of the supply curve. You find the new equilibrium quantity, QT. You find the price that consumers pay at that QT. You find the price that producers receive at that QT. You compute the each of those surpluses. You find the tax revenue, which is the rectangle, that green rectangle in the middle, equal to the per unit tax times the quantity produced. And then you can also find the area of that deadweight loss, which is the value of those beneficial trades, which cannot happen because of the tax artificially increasing the price. There's a little bit of micro material remaining. I don't want to spend too much time on it. It's review from your principles of micro course, and there's a good summary of it in the book. But elasticities essentially are just the percentage change in the quantity divided by the percentage change in the price. That's a demand elasticity. So again, we're interested in that because as a policymaker, if we know something about how people will behave in response to a change in price, that could give us some hint as to how effective an incentive might be in steering producers or consumers in a particular direction, right? So if we're talking about demand, um, we're talking about demand. We have demand elasticity. There's different ways of classifying goods according to how their demand elasticity is structured. Basically, demand elasticity just relates to the steepness of the curve. A steep demand curve is going to be inelastic, and a shallow demand curve is going to be elastic. Those are the elasticities with respect to the good's own price. Elasticity is going to be higher when there's a larger number of close substitutes. When the item makes up a large share of the household budget, you're going to be a lot more responsive to price. You're going to be paying attention a lot more to price for something like a car than something like table salt. If the price of table salt goes up, you might reduce your consumption a little bit, but you may not even notice, and you might not even change your behavior at all if that happens. And then as the longer time period is being considered, you have more and more time to make adjustments to that change in price. So you'd be more likely to change your behavior in response to a good in the long run relative to the short run. You have more opportunities to adjust in the long run. So you'd have a higher elasticity for something the longer term you're talking about. If you're talking about something like gasoline, you're able to, if the price of gas goes up, in the long run, you're able to do things like switch the car that you drive, or even relocate to a place closer to work, which will reduce your quantity demanded. So how long you have to adjust is going to be something that affects the elasticity of demand. There's also something called a cross price elasticity, which is the change in quantity for the percentage change in quantity for a particular good divided by the percentage change in price in some other good. So if this is positive, if this cross price elasticity is positive, then we have the goods being substitutes for one another. We have petroleum and natural gas, or coal and natural gas, or something like that, which are, you can, if the price of one goes up, you can switch to the other. And so if the price of natural gas goes up, you could switch to petroleum, and the demand for petroleum would go up as the price of the other good goes up, because they're close substitutes for one another. If the cross price elasticity is negative, let's say you have a case where those goods are complements. So if the price of gas goes up, SUVs are going to become less attractive because they guzzle more gas, they consume more gas, and it's costlier for you to drive an SUV when gas prices are high. So as the demand for SUVs go down when gas price is high. The demand for SUVs would go up when gas price is low, and so that would be a case where you have a negative cross price elasticity. And then you can have things like goods that will change in their quantities demanded when your income goes higher or lower. So if a good if the good is a normal good, most goods have this normal good property where you buy more of it when the price goes up. But some goods actually might have the opposite characteristic, where you buy less of it when the price goes up. That would be an inferior good. You reduce your consumption of maybe things like off-brand grocery products or public transportation. You might reduce your consumption of that as you get more income, and you want to just use a private car. So there's different ways of categorizing goods according to these different rules, or these different values for elasticities. That's all summarized here on these slides, and there's discussion of it in the book. What I wanted to do here now is we're kind of finishing up with this micromaterial. I wanted to just give a little bit of a review assignment to recall and review some of what we talked about last week about sustainability. So I have here an in-class assignment that I want you to work on for about 5 minutes. So remember, this is part of your kind of attendance and participation grade. Take 5 minutes or so and try to answer these questions. What I want you to think about, going back to last week, is how is strong sustainability different than weak sustainability? What is the key assumption of weak sustainability? What's the key thing that they're assuming to be true, which sort of upholds their point of view? And then in what way does the safe minimum standard represent a compromise between weak and strong sustainability? So we talked about this last week. You've had a little bit of time to forget about it, and I wanted to just kind of bring some of that back to your mind, refresh it, review it, give you some time to think about it. Take 5 minutes and write out some short responses to that. And then I have a Dropbox that I created on Moodle, which I think is going to work. And try to submit your responses on that Moodle Dropbox. Okay, I think I'm going to come back just for the final 5 minutes and just give a little bit of introduction to our next section, which is going to be the theory of externalities. So the work we've done in this microeconomic analysis is going to come in very handy when we try to analyze externalities. So just kind of an overview of where we've come. We just finished up this section up top, going over themes in environmental economics, reviewing some micro, and now we're going to be digging into some of the core theory. This is the first part of the theory section. But to motivate this and to give some, kind of a narrative that you can use to frame some of this discussion that's going to come up, or frame the analysis that's going to come up. There was an interesting case in 2014 where agricultural producers in Ohio were applying nitrogen and phosphorus to their land, manure, and other synthetic fertilizers to help grow their crops in northern and central Ohio, and those nutrients were being washed off the soil and into Lake Erie. And when those farmers were making those transactions for that fertilizer, either they were buying manure for application on their cropland, or they were buying synthetic fertilizer for application on their cropland. They weren't accounting for the fact that some of those chemicals could run off into Lake Erie and cause problems for the city of Toledo. And what happened is the city of Toledo gets its municipal water supply from Lake Erie, and the excess nitrogen and phosphorus that was building up in Lake Erie produced some blooms of algae, some of which produced a toxic chemical called microcystin, which is difficult to treat. It's not treated by standard water treatment processes, and an algae bloom sort of came up right near the intake valve for Toledo's water supply, and there was a lot of water that they brought in for their water supply, which was contaminated with this microcystin. And for almost 3 days, almost 3 complete days, in August of 2014, Toledo Mayor Michael Collins over here, he issued a do not drink advisory. There was actually they issued a strong advisory saying you do not drink your tap water, you're going to get sick. And it was an extreme inconvenience to the city of Toledo. There was people that had to go on this right hand panel. A lot of people were rushing to the store to buy bottled water. Some of them were going across state lines to buy bottled water. And you had this period of like a Friday evening to like a Monday morning in August of 2014 where you couldn't use any tap water. So this transaction that was taking place for farmers in upland Ohio had this huge effect on residents and had this huge inconvenience for residents of Toledo. And that's an example of an externality. That's an example of some transaction which has an effect on some other group of people who didn't have any voice in how the producer was originally using those resources. So that's kind of a story to kind of motivate what we're going to talk about next in externalities. I'll pick up with that material on Wednesday. So we'll start Wednesday with this next section on the core theory of externalities.